Now, first of all, know that lasers are an invention that was enabled by quantum theory, quantum mechanics. So if anybody ever tells you that quantum mechanics or advanced science has no use, you need to let them know that the entire internet runs on quantum mechanics, because the fiber optic cables that crisscross the globe carrying information are carrying that information in laser light inside of those fiber optic cables. So there's many applications, medical devices, surgical devices, but communications is really where lasers have completely taken over everything. All right. So what is a laser? We have to talk about that first before we can describe how it works. The word laser stands for light amplification by the stimulated emission of radiation. Now, in this context, when I say stimulated emission of radiation, I'm talking about radiation being not something that hurts you. Laser light is radiation. All electromagnetic waves are light waves, and they're all considered radiation. So when I say stimulated emission of radiation, I just mean stimulated emission of light. So there's some amplification going on. There's stimulated emission of radiation, which is more light. So what the word is telling you is there is photons stimulating more photons to be created. Light amplification and stimulating more radiation, which is more photons. So what we're going to find in a nutshell is that inside of a laser, there's an amplification process where it's a cascading chain reaction where one photon can trigger additional photons to be released. And then those photons can trigger more photons to be released, and more and more and more, and that's the amplification going on. And then through the process and how it's built, we can focus it into a beam, which we see as a laser. Learn anything at mathandscience.com.